Welcome back to another AP Pre-Calc video. Today we're looking at our notes 2.10. 2.10, we're continuing this idea of logarithms, but now we're starting to get into log properties. First three properties of logs are pretty basic, and if you memorize these properties, this process should be very, very quick because you can just look at where things are and convert between condensed or expanded forms. For example, log properties are the opposite of exponentials. So all of these properties are derived using your exponent rules. If you want to look at those proofs, let me know. We can talk about those a separate time. I will not include the proofs in this video right now, but we can look at proofs later on. So if you have something like this, if you have multiplication inside the log, that can be turned to addition outside, or vice versa. Same idea, but with division in the log, that can be changed to subtraction on the outside. And if you ever have an exponent on everything inside a log, that can be moved out of your log as a multiplier. I usually talk about that as being thrown to the outside. Okay, well, let's look at these different problems then. This first group of problems, we're trying to expand the log. So if I have one log, I want to make multiple logs. I want to expand. Well, I notice that the 2 and the x are multiplying on the inside here. Well, if you have two things multiplying in your log, you can change that to two separate logs where those things are adding. Notice the two separate logs have the plus in the middle. They both still have the same base of 3. And now we just separated the 2 and the x. Same idea for this next one. They're dividing. In order to divide inside the log, that means we can separate to make two different logs where they are subtracting. Again, the base of the log stayed the same. One thing you might do on this problem is log base 4 of 16. You might even try and simplify that if you want. Log base 4 of 16, that's 4 to what power is 16? You could even change that to 2. Do you need to do that? No, but that is something that we might know because we've talked about it before. The next one, there's an exponent on it. Whenever you have an exponent in the log, you always move it out front. So this is now 3 times log base 5 of x. The third got moved to the front. Looking at C, I see there's multiplication, so I can separate the multiplication with addition of separate logs. So I could have log. Notice it's a common log, so the base is 10 technically. So log of 2. That would have to get added with another log. Log of x to the third gets added with another log. Log of y to the third. Okay, but some of those have exponents, so we need to deal with that. Move those exponents to the front of their respective parts, where the 3 is multiplying with both those logs, and now you have your your expanded form for C. Realize I normally don't show my work for this. I usually jump straight to the final answer. For example, let's look at E. What I see is a log. This log has division, so I know that I need two separate logs where those logs are subtracting. That's one part I notice. One of my logs should be log of x. The other log should be log of y. You can include the parentheses on that stuff if you want. But I also notice this stuff has exponents. If it has an exponent, we always move the exponents to the front of those logs. So the one that has the x, I could move its squared, or the 2 out front. The one that has the y, I could move its 3 to the front of that one. I normally don't show work. I normally just apply the properties quickly. For example, if I did f, you might rewrite that one first, where y to the 5th and the square root of that is just y to the 5 over 2. So now I have something like this. Okay, expand it. So I need anything log of y on the top. The 5/2 is its exponent. I move exponents to the front. X to the 5th and z are both being divided. So both of those are going to go on the bottom, and I show that with my subtraction here. Okay, but the x had an exponent of 5, so I move that 5 out front. The z is on the bottom, so I can subtract it. Subtract log of z. There is no exponent, so it doesn't have one in front. Super simple idea once you know your rules. Okay, we can do the opposite. We can reverse that property and condense the logs. Both these logs are the same base, so I can make them one log. Log base 2. They were adding in between the logs, so that meant these logs were multiplying. X and Y were multiplying on the inside. Part B, log base 3. They're subtracting, so that meant those two parts were dividing on the inside. Part C, there's a number in front. That must mean there is an exponent on the x when you move it to the inside. And we can continue that process for each of these, looking at maybe some more challenging examples like D. Okay, I'm going to make this all one log because they have the same base. I have an exponent on the 3, so I'm going to move that 3 back in. Notice this first log with the x is positive, so that log would go on top. So that would be log of 2 with x to the third on the inside. This 4 is negative here. That must mean it was dividing, where x plus 3 would have an exponent. I don't know why it doesn't like to write today. It's really been struggling. Good thing I ordered a new pen. Okay, the x plus 3, we move that exponent into it as well. So that whole group now has an exponent of 4. Okay, but then this last one, it has a plus on it. So, okay, adding means it's multiplying, so that's going to be on top, where there's a y with no exponent in this case. So now I have something like that. Other ones, maybe you look at E, move the exponents to the inside. So the x has the 1/2 power. X plus 1 has the power of 3. Notice all of that is within that same log. Okay, same sort of idea. Even if it's natural log, same idea there. You can keep it as ln, natural log. Divide by the x because it's being subtracted. Okay, basic idea for us. Last type of problem you might see is, okay, if we're using these properties, and I'm given something like this, but I also know what some of these logs are equal to. Well, right now I don't know just what is log of a. I know what log of a to the 6, c to the 5th, all of this is, but I don't know the singular parts. So I could find those by expanding this, moving the exponents to in front of their respective part. So there, I could have this as 6 times log of a plus 5 times log of c. This is on the bottom, so that means I'm subtracting. B, the cube root of b squared would be b to the 2/3 as a fractional exponent. So I move that 2/3 out front, and I have log of b there. Well, we know what each of these parts is equal to. I know what log of a is. When I look at the top, log of a is just -4, so that needs to multiply with the 6. The 5 needs to multiply with whatever log of c is, which in this case is 8. Same thing with log of b. Figure out what it multiplies with, which is this -12. You could simplify that real quick. Negative times a negative. 2/3 times 12. You might divide by 3 first, giving you 4. 4 times 2 would give me 8. So that would end up just giving us a total or final value of 24. Thanks for watching. That is our 2.10 video. 2.10, looking at some logarithmic properties.